Okay, let's take a look at how you can factorize quadratics when the coefficient of x squared is greater than 1. So for example, the coefficient of x squared in this example is 2, which is clearly greater than 1. The issue with when the coefficient is greater than 1 is the factorizing process is quite a bit more challenging. So for example, normally you might have questions like x squared plus 10x plus 16, right? And this means that the coefficient of x squared is just x, right? So that means when you factorize into the brackets, let me just write this in a bit more of a straight manner. So you have x and x at the start of your brackets. Then what you do, you just find two numbers that multiply together to give this digit 16, and two numbers that add together to give the value of 10. Well, what factor pairs do we have for 16? We have 8 times 2 is 16, and coincidentally they add together to make 10. So it's going to be plus 2 and plus 8, right? If we factorize this out, we're going to get x squared plus 8x plus 2x, and these two, remember, they multiply, so they make plus 16. But when we have a coefficient of 2 or a coefficient of 10x squared, that's when the process gets a lot more challenging, because the numbers in front could be 5 and 2x. It could be 10 and 1x. So there's a lot of possibilities, and then the process of the two numbers just multiplying to make the last digit, adding to make the middle digit, does not work. So let's look at the method that you would use when the coefficient is not 1. So the question is going to be 2x squared plus 9x plus 10. And some people teach a method that works when the coefficient is 2, but this method I'm going to teach you guys now will work regardless of the coefficient. So if it's like 10x squared, 20x squared, 6x squared, it will always work. So 2x squared plus 9x plus 10. So we're going to have a new method. Of course, you can still solve this using trial and error. It's going to be really time consuming, so I do not recommend this. So there's two key rules to understand. These two, the last two digits multiply, and then the middle digit stays the same. So this digit is going to stay the same. So two numbers are going to add to make 9. The middle one stays the same, and two numbers add to make it. The last two digits multiply, and two numbers multiply to make it. Pretty easy to keep up, right? Let's look at the factor pairs for 20. We can have 20 times 1, but that's not going to add to 9. We can have 5 times 4, which will add to 9, right? 5 plus 4 is 9. So let's put 5 times 4. And 5 plus 4 will make 9. Now, we're not done. There's a couple more steps to do, and this is really where it gets confusing. Okay, so we have our original equation of 2x squared plus 9x plus 10, right? This 2x stays the same, right? This 2x squared is going to stay the same. And instead of a 9x following, now we're making the factor bracket, not really the brackets, we're still not done. We still have 2x squared. And then the first digit, the number that we put here, is going to come right after. Like so. The second one, remember we're gonna have to make two brackets, right? Second one, the 4 now comes along. The 4 comes along to give us 4x, normal x. Remember, there's only one x squared, so it's just gonna be normal x. Plus, and then the last digit just stays the same. It doesn't change. You'll already notice that these two multiply to make 9x. Kind of see something happening, right? 10 is here, and you have 2x. What we're going to do is factorize this out now. When we factorize 2x squared plus 5x, we get 2. Actually, we can factorize the x out too. 2x squared, so another x. And sorry, you can't factorize the 2 out, just x. And that's going to be 2x squared plus 5x. And this is just going to be 2x 2 oh, there's no x there because we only have one x, plus 5. Now what you'll notice is once you've done this, you should get two brackets that are identical. That is not our answer. That forms part of our final answer, 2x plus 5. And we have an x and a 2 left, right? Those two form the second bracket, x plus 2. And what you'll notice is once you multiply this and expand it, you'll be met with our original answer. So just go through this again. We take the two last digits, they multiply to make 20, and then two numbers also multiply to make 20. So the two digits at either end multiply, and two digits also multiply to make it. The middle one stays the same. Now if your equation is arranged in this order, obviously you're going to have to rearrange it, right? The middle one is not just always the middle one, it's the one with no x squared, just a normal x. Middle one just stays the same, and two numbers also add to make it. So the two digits multiply, and two digits multiply to make it. The middle digit stays the same, and two also add to make it. Then we have to make our two equations that we can use to make our factors, right? So our x squared coefficient stays the same. The x squared stays the same. The first digit comes over and becomes the next 5x. The second number comes over and becomes the second x, and the last digit stays the same. So the start and the end will always stay the same. Then we take each equation and we factor it, and note that when you do factor it, the two brackets formed must also be the same, and that will be the 2x plus 5, and then the remaining digits form the second bracket. Now note, if you did this saying like 4 times 5 instead of 5 times 4, like so, that will also work. That's going to give you the same answer. What you shouldn't do is you shouldn't do like this. Well, it doesn't really matter because you're only going to use one from each side anyways. But just note that the direction of your writing doesn't matter, but keep each row the same. The column, I mean. Keep each column the same. But the order of the numbers doesn't really matter as long as both rows have the same arrangement. Let's look at one more example to kind of solidify. 3x squared plus 10x minus 8. Okay, this time you should sort of be getting the hang of it. The end two digits multiply, so two digits also multiply to make it. And two digits multiply, two digits also multiply to make it. And remember, note the minus symbol. It's going to be a minus 24. The middle digit stays the same, right? The middle digit stays the same. So two numbers just add to make the middle digit. We're going to have two numbers that multiply to make negative 24. What do we have? 6 times negative 4. We could have negative 4 times 6. 12 times 2, negative 2. Oh, 12 times negative 2 works. 12 plus negative 2 makes 10 too. So we're going to have 12 times negative 2. Actually, just to show that the order doesn't matter, I'll put negative 2 first this time. Negative 2 and 12. And we also have negative 2 and 12, which satisfies our needs. So the two end digits multiply, and two digits also multiply to make it. And note the symbol, that's important. And the middle digit stays the same, and two numbers add to make it. Then we can start making our equation. The x squared always stays the same. And then we take the minus 2, and that becomes our first x. Second x is from the second row. So 12x, and our minus 8 stays the same. Then we can factorize each one out. 3, we only actually have x that we can factorize. 3x squared minus 2, and this one is just 4. Yeah, 3x minus 2. And you'll notice our brackets are the same. So in conclusion, we can write our answer as 3x minus 2 and x plus 4. If this happened to be a minus 4, then that would be a minus 4, wouldn't it? But because it's not, it's just going to be x plus 4. And that really is how you factorize quadratics when the x squared coefficient is greater than 1. Hope this helped, and thank you for watching.